Welcome to Real GMAT Problems, episode 34. Doing real GMAT problems is one of the most tried and true ways to improve your performance on test day, so let's talk through a few examples. The problems that we're going to go through are from the 11th edition of the official guide for GMAT review, and you can web search them if you'd like to follow along visually. Just so you know, the 11th edition of the official guide is out of print, and that's partly why I'm going through questions from that book, because that way, if you purchase this year's official guide, which is a great resource, there shouldn't be any overlap between the questions that we're going to work through here. The official guide contains retired problems that have appeared on past GMAT exams, so these are going to be extremely similar to what you're going to see on your official GMAT. I'll give you a chance to work through the solution on your own if you'd like, and then I'll discuss my thoughts on what to take away from each example. I recommend pausing after I read through each problem and trying to solve it, or at the very least, visualize how you would solve it. If you're on the go, you might not be able to execute all the steps in your head, but just get as far as you can. It's an excellent mental workout, and you should find that your scrap paper techniques and your strategizing works better when you get back to the desk and the paper. If you are in a situation where you can physically write down what you would on test day, that's definitely ideal. Let's start with a warm-up problem, and then we'll explore some more complex questions that build on a couple of the central lessons that we're going to explore today. First problem. During a certain season, a team won 80% of its first 100 games and 50% of its remaining games. If the team won 70% of its games for the entire season, what was the total number of games that the team played? I'll read that again. During a certain season, a team won 80% of its first 100 games and 50% of its remaining games. If the team won 70% of its games for the entire season, what was the total number of games that the team played? Option A is 180. Option B, 170. Option C, 156. Option D, 150. Option E, 105, 105. So wanted to dig into some longer word translations, some deeper dives on word translations specifically. And I'm really hopeful you're going to find a lot of value out of this because this type of question in particular that we just talked through, it's heavy on percents, it's heavy on words. If you haven't paused and worked through the problem yet on your own, please make an attempt at that. I'm just going to jump right in here. Percent word problems are some of the most common that appear on the quant section. Almost always a good bet to practice those. So it's a very good warm-up problem for the lesson, but also it's somewhat long. It's certainly not the longest word problem that you're going to see, but it's a good example of what happens to a lot of people on long word problems. And I'm going to try to build on that as we go through our conversation. Another reason it's a good warm-up problem is it's pretty intense when it comes to organization. You've probably heard me say in the past that most word problems are more of an organizational challenge than a mathematical challenge. And I think the more of these GMAT quant word problems you do, the more likely you are to find that to be true. We'll follow up with a couple more examples of that as we go. For now, let's explore one way to get this problem right. There's actually a couple viable solution paths. All of them are good. For the sake of simplicity, though, I'm just going to focus on one of them, but I'm going to put more emphasis on the concepts that I think are going to apply no matter which solution path you decide is best for you. And I think that's what most of us need with word problems at virtually all stages of our prep, certainly at the beginning, but even deeper into your prep. It's like choosing the right strategy is extremely important. Don't get me wrong. Like you definitely want that and you want to work on that. I'll give you some advice, and I've given a lot of advice in past episodes about how to improve with that. But I also think the process piece can use a lot of emphasis, and I don't think that's as emphasized in a lot of paid programs that I see on the market and in a lot of free content out there. So going to try to fill in that gap for you here. let's just jump right into this solution and I'll talk about the themes that I was just discussing more as we go. So the first key to a great solution to a problem like this is just writing what's given and asked clearly. That should come as no surprise if you've been following me for some time and this content for some time, but um, it doesn't make it any less true. And for some of you, that might even sound redundant or maybe even like overly obvious, but even so, you might be surprised how few people do this well consistently. It's actually not that hard to do things well once in a while. But to do things well 100% of the time, that's usually really, really, really challenging for people. In fact, if you're struggling to be consistent in general, whether that be with your study time or your approach to questions, or just basics like sleep, diet, exercise, etc. We've got an episode on how to be more consistent in general, specifically related to the GMAT and your GMAT prep. That's linked below for you. It's not medical advice. I want to be clear about that, but it should be super helpful. Let's assume, though, that you've written everything that's given and asked on this problem clearly. Where do we go from there? I think some people see obvious places to start. But if you're ever unsure where to start, once you've got the given information mapped out, look for any places that you can combine pieces of information or make simple calculations. So again, I just want to reemphasize this. What I'm about to do is not the only way to do the problem. If you see an obvious place to begin the problem, then you don't have to take the advice I'm about to give right now. Go for what you see and get momentum. No, however it makes sense to you. But I'm more speaking to folks who like feel like they're stuck or dead in the water. Like, okay, I like wrote everything down. Like now I'm staring at my page. Where do I go from here? I'm like frozen. Um, so in this case, I can see that 80% of the first 100 games are wins. And I know I can make that calculation relatively easily. So that's a great place for me to start. And that's what I'm recommending. Just look for something you can do to get some kind of momentum. Oh, I can see how this piece goes with this other piece. Maybe you can't see your whole way through the problem. But usually with complicated problems or organizationally intense problems, if you can just solve one small piece of the problem, then that can often unlock the next step. This is a good example of this. So um, this first like 80% of the first 100 games, it's valuable. It captures an important aspect of the problem. It generates momentum. And that's where I'd probably begin, just writing out that I've got 80 wins out of the first 100 games. And I might just literally write that out. I would probably also write 80 over 100 times 100. But that's me because I like to be super, super hardcore with my scratch work. I really, really hate missing questions I know how to do. And it happens a surprising amount of the time, even at my level. And you don't have to do that, just to be clear. If you're never making those kinds of mistakes or never missing problems because of that kind of thing, like, you know, I'm never gonna criticize your results. Um, but if you're not getting the results you want, then I encourage you to write more down. Like as simple as that might sound, it should make a very positive difference. So I'm just going to start by writing at the very least 80 wins out of the first 100 games. That might not seem like a big deal, but I have a little bit of traction on the problem now. You might recall from some of our recent conversations about word problems specifically, how useful it is to organize information in simple tables with rows and columns. And while I don't think that's essential here, I think you will probably find it pretty valuable. And this is especially true if you're like, okay, I got 180 out of the first 100 games. Now what do I do? Now I'm like stuck again. I'm frozen again. So a good way to recognize when it's going to be valuable to use rows and columns to organize what's happening in the problem is when there's some kind of comparison. This could be tickets to a show for adults versus tickets to a show for children. Some kind of comparison like that in the problem. Or maybe like 2023 prices versus 2024 prices, or 2023 sales versus 2024 sales, or revenue versus profit, some kind of comparison. A recent question we worked through together had workers on a day crew and workers on a night crew. That's also like a good signal, like probably going to do some rows and columns here to get myself organized. Anytime you're comparing groups, you're comparing time periods, maybe you're comparing parts of a whole, rows and columns, likely to make a hugely positive organizational effect. And it's just going to make questions that are a challenge to organize otherwise a lot easier. Now, I can't say that's true 100% of the time. Obviously, if you're implementing the strategy and it's not working for you, there's plenty of alternatives. And you can feel free to reach out to us anytime. We're at the GMAT Strategy on current social channels. You can email us, contact@thegmatstrategy.com, and we'll do everything we can to help you out. If we can help you out for free, we'll absolutely do that. And I would say like 99% of the people who DM us, that's what ends up happening. Um, so yeah, feel free to reach out if this kind of stuff is not working for you and you feel like you need a different approach and you're having trouble finding good advice elsewhere. Going back to this problem, do you notice anything in this problem that might suggest a comparison or parts of a whole? I'm looking at things like games won versus total games, or first 100 games versus the rest of the season. Those are comparisons of time periods or parts of a whole that would suggest might want to use some rows and columns. And those are good cues to look out for in future problems as well. So once you're starting to see things like 80 wins out of the first 100 games, even though that might seem like a trivial part of the problem, that sometimes is enough to trigger like, oh, I've got a part of a whole, or I've got like a comparison happening here. And that's what I'm talking about. Like sometimes just solving that one piece of a larger problem can unlock somewhat unexpectedly like the next potentially positive step. So what I might do here is then make a column header that says wins, and then make another column header that says games. That's like the part to whole relationship I'm talking about. Of course, you can organize this a variety of ways. I'm just giving you one example. Underneath wins, I can put 80, and underneath games, I can put 100. Then I would probably label that row with 80 and 100 in it as first to indicate that's the first part of the season. So now I've got a good organizational system going that should make life easier as I progress. Then what I like to do is just go back to the problem and ask myself, what given information have I not used yet? It's extremely unusual for quantitative questions on the GMAT to present you with information that you don't need to answer the question. So if they're telling you it, it's probably essential for answering the question. So if you get stuck, it's good to go back and ask, what given info have I not yet used? That's often a key to the next step. So here we're told that 50% of the remaining games are wins. I'm not told how many more games they played, though. So that's an unknown, which suggests I'm probably going to want to make a variable for that. Let's call that R, the letter R, for remaining games. In my chart, I can just make a new row under the first row, and I'll just put like next or remaining to indicate that that's like the rest of the season. And under games, I'll put R. I'm using that to represent the rest of the games they played for the second part of the season or next part of the season. And then under wins, I'll put 50 over 100 times R. And that captures the wins and total games after the first 100 games that are played. So again, you might have no idea how you're going to get to the solution from here, but if you can just keep solving one small problem after the next small problem after the next small problem, it's highly likely you're going to be able to get it across the finish line. And the table is a good way to make that progress and build momentum in the question without getting lost. Really, really valuable for word problems. At this point, I'll move to the next piece of given information. Again, just repeating that process of like, okay, now what do I do? Well, let me go back. What other stuff did they tell me about that I haven't used yet? And they tell me that 70% of the games in the entire season are wins. And I don't have that organized or like attached to anything yet. I don't have that in my chart yet. But basically, I can recognize, that that's telling me about the total games and the total wins. So I'm going to make another row under my first two that's just called total. So I'll have first, and then I'll have like next part of the season, and then I'll have total season at the bottom. And under the games column, I'll write 100 plus R. That's the first 100 games plus the unknown R games remaining in the season. And then under wins, I can now write 70 over 100 times 100 plus R to represent that's the total wins for the whole season, 70% of all the games. And I think at this point, that table makes the final connections that we're about to make to solve the question way easier for most people to make. Some problems are just flat out hard. We're not going to be able to make them easy, but we can make them easier by using go to organizational strategies and just being consistent in our approach. More on that later. For now, though, let's stay focused on this problem. Hopefully you can see that you can take the top two entries in the wins column, that's 80 for the first 100 games, and then 50 over 100 R for the next remaining games, and add those together. And if you add those together, that should equal the total wins for the whole season. We just wrote an expression for total wins for the whole season. So now we can make an equation, and equations are great in these kinds of questions because usually that means I can solve for the unknowns, which is what I want to do here. So that equation could be 80 plus 50 over 100R. That's the total wins from the first and second part of the season that we're told about. And then we can set that equal to 70 over 100 times 100 plus R, which is 70% of all the games played. And we know that's also equal to the total wins. Now, I just want to re-emphasize here, plenty of you probably do not need these rows and columns in order to make those connections or get to that equation. That's totally cool. I'm not saying you have to do this. Again, I'm never going to argue with your results. If you're getting incredibly good results without doing anything I'm talking about here, don't stop what you're doing. Don't take my advice. Just keep getting incredible results. But my guess is you will probably benefit from using a table like this, even if it's on harder or more complicated questions where maybe it wasn't as easy or automatic to get that stuff to come together. So yeah, hopefully I'm just showing you how you could recognize when it could be a good idea. And then it's up to you to experiment and figure out what's going to work best for you. Now, for others of you, you'd be totally stuck in this problem without the rows and columns. So hopefully that makes the problem a lot more solvable at the very least, makes it faster. Now, it's probably worth noting, and I've talked about this in the past, that it might feel slower. You might feel like you're going too slow when you're setting up the problem. But the objective of the exam is not to feel good. There's plenty of other things you can do with your life to feel great that are going to work out a lot better than than this, unless you love really hard puzzles or really difficult standardized exams that just get more and more difficult the more your skills grow. And if you don't know how the scoring algorithm works, we've got a video on our website. And that's linked below, but it's just the gmatstrategy.com. I recommend checking that out. It'll teach you how to deal with the scoring algorithm and how it's different from other exams. But yeah, the test is adaptive as you get more questions right. The questions that the exam shows you are more difficult. So it's a very, very difficult exam by nature. And again, this just comes back to like maybe we can't make it easy, but we can make it easier, and we can definitely make your score represent your skills better by adding some technique and some process and some fundamental habits that I think you'll find quite valuable. So that's what I'm doing my best to share with you here. Okay, so back to this question. We've recognized that there's a comparison here, wins versus total games. And we used that information to create some rows and columns. And then we just started calculating based on what was given. And then we ended up figuring out a relationship we can use to solve. So that's the basic workflow on a lot of these word problems. You're just going to be doing those things that I just talked through over and over and over again. There's tons of ways to solve the final algebra. I'll walk through one potential way to do it in a moment, just in case it's helpful, but I'm going to just gloss over that for a second, make a couple points just so we don't get lost in the details, and then I'll double back on the details for you if you find that valuable. So if you execute the algebra well, you're going to get that R is equal to 50. And this is also a place where having the rows and columns can really help you out, because you hopefully will be able to see like 50 does not represent what the question's asking for. You want the total games played. That's what the question's asking for. And as part of our table, we've got 100 plus R written in the total row underneath the games column. So hopefully that would help you see that the correct answer is going to be 100 plus 50, which corresponds with answer option D, as in delta. Now, it's another good point to make here that it's great if you wrote down what the question was asking you at the beginning, because then you're unlikely to make a mistake or like add 50 to the wrong thing, or just get stuck and say like, wait a minute, I got 50. I must have done some math wrong. Sometimes just that last connection in the question is the most difficult piece on word problems. And that's just because there can be a lot of steps in there. But back to the speed thing, like even though it might feel slower to write the question down at the beginning, or it might feel slower to write the rows and columns down, you'll usually see if you time your practice questions that the clock time to finish is lower. So you might spend a little bit more time setting up, but usually that investment pays off on the back end of the problem by making it a lot easier to connect the dots. And you also might notice that if you speed through the setup of a problem, you might feel like you're going faster, but the total clock time is longer. So I'd encourage you to experiment with that and just make your decision based on the numbers. You don't necessarily have to take my word on any of this stuff. Like test it out for yourself, use the data, and I think you'll find that it works out in favor of what I'm saying. But everybody's different. I definitely don't want you taking this advice if it's not going to help you. So please test and please validate. Trust but verify, as they say. So in that part of our table for total games played, like we said, we got 100R. That gets us to the answer. And again, I'll walk through that algebra in a sec. But just in case the organizational piece is really where you want to focus going forward, now could be a good time to pause and just make a quick note to self for what you want to remember or take away from this problem. If you're on the go, you can just send yourself a quick text or email and remind yourself to make a note about it later. But if you liked the writing what's given an S thing, that's a good takeaway. If you like the rows and columns thing, that's a good takeaway. If you liked what I was talking about how to recognize when you want to use rows and columns, like if there's a comparison or if it's part of a whole, also good takeaway. But maybe there's something else that you realized here from our discussion, and I'd encourage you to note that to yourself as well. Okay, just quickly solving the algebra, let's bring back our equation. It's 80 plus 50 over 100 times r equals 70 over 100 times in parentheses 100 plus r. I'm just going to go through this kind of quickly because I've done a lot of algebra on the podcast. But if you want some brushing up on your algebra skills and your equation solving skills, then we'll have a Math Basics episode linked on that for you below. And that should really help you upskill or reskill with equations if it's been a long time and you're just starting out your prep, which is the case for many of us. Let's distribute the 70 over 100 on the right side of the equation. That gets us on the right side 70 plus 70 over 100 times r. And then let's combine some like terms by subtracting 70 from both sides. So on the left, we've got 80 plus 50 over 100r. On the right, we've got 70 plus 70 over 100r. So I'm subtracting 70 from both sides. On the left, that gets me 10 plus 50 over 100r equals 70 over 100r. Let's subtract 50 over 100r from both sides to get 10 equals 20 over 100r. Let's reduce 20 over 100 to 1/5. We've got an episode on fractions, Math Basics with fractions, linked below if you're not sure what I'm doing there. And then that gives us 10 equals 1/5 r. Multiply both sides by 5 to get r equals 50. So again, many ways to solve the algebra there. That's just one way. And just talking you through that just in case that was a place where you got stuck or couldn't figure out what was going on. If you want to brush up on any of that, like I said, we got those Math Basics episodes below, and that's where I started. I had to brush up on all this stuff. I had forgotten tons of Math Basics by the time I got around to studying for the GMAT, and it's a totally fine, acceptable place to begin. And that's why we made all that Math Basics content for you. So just putting a bow on this one. As I said before, there's other ways to conceptualize the problem. You don't need to use rows and columns, as I'm suggesting, and you don't even need to use the kinds of equations I just walked you through. But in order to make this problem, as useful as possible for as many people as possible, I chose to just focus on those elements. Since the shortcut methods, they're probably going to make sense to anyone who's got a lot of experience. And the shortcut methods that you might find elsewhere probably won't make much sense if you're just starting out. So I've tried to be kind of like process neutral or approach neutral and just try to give you what I think will be the most usable no matter which steps you decide to take or which strategy you find most appealing. Or where you are in the prep process, beginning, middle, or end. But I did want to mention that these aren't the only methods that you can use to solve. Just one more time, I really like to emphasize that as much as possible. If you find a different method you like, chances are that's going to be a great bet for future problems that are similar to this one. No need to change what you're doing if you're already having success, like I said before. Now, I chose this one as a warm-up because there doesn't seem to be a major pitfall on this problem. Most of the wrong answers are just evenly distributed between A, B, C, and E, the other options. So it looks like people either know how to get this right and then they get it right, or they just get totally stuck and like guess randomly. So that's where I thought having some process help could be valuable. If you're struggling with word problems in general, either the translations part or the comprehension part or the speed part, the fundamentals that I just discussed, which is prioritizing good organization, should help quite a bit. Having said that, I do just want to make one final mention here. It usually takes more than just a handful of problems to build speed with word translations, and it often takes quite a bit of effort, so don't be afraid to start slow. That's where I started, and it took me a lot longer than I wanted it to build a good approach and build speed with these but it's more than worth it. So don't be afraid to put a lot of energy into your word problems approach. Don't be afraid to put a lot of energy into your word problems practice. Again, percents and word problems are two of the most common topics in the quant section. So any time spent there is generally time well spent. Okay, now that we're warmed up, let's try a couple more examples of word translations. I'm going to try to stick with that theme for the rest of this lesson, and we're going to build on the basics here. Next problem. The problem says Jack is now 14 years older than Bill. If in 10 years Jack will be twice as old as Bill, how old will Jack be in 5 years? I'll read that again. Jack is now 14 years older than Bill. If in 10 years Jack will be twice as old as Bill, how old will Jack be in 5 years? Option A is 9. Option B is 19. Option C is 21. Option D is 23. And option E is 33. Again, recommend pausing here. Get as far as you can on your own. Really interesting follow-up to the previous problem, I thought, because on the surface, I think this one looks a lot simpler. But it turns out that while 13% of us missed the first one, 20% of us miss this one. So it definitely appears to be a bit more challenging. Let's dig into that. Let's see if we can make this particular problem easier and age problems in general a bit easier for you, because I think a lot of people find them pretty painful. Let's start with the fundamentals. Just write what's given and asked. We're told Jack is 14 years older than Bill. We're given a relationship between their ages 10 years from now, and then we're asked for Jack's age in 5 years. So you'll want to note that however it makes sense to you. Like the previous problem, there are a few different approaches that can work. So I'm just going to go through one, but again, I'm going to put the emphasis on the process, like things that you can bolt on to however you like to strategize here that should be helpful. Some of you might be super comfortable going straight to algebra and using equations. Some of you might be able to reason your way through the problem using logic. Others of you might feel more comfortable plugging in the answers and guessing and testing. All those approaches work well if you're comfortable with them and you execute well. So once again, let's focus on the execution part, and let's try to build good habits. Let's start on this one with where most of us seem to be going wrong, and then we'll use that to build out a system that'll minimize the risk. A lot of folks don't struggle with that first piece of information. If Jack is currently 14 years older than Bill, we can create a variable for each one and make an equation something like J equals B plus 14. A lot of folks can get there, but then it's clearly very tempting to do the next part of the problem incorrectly by translating the if in 10 years part wrong. So it says if in 10 years Jack will be twice as old as Bill. A lot of folks go for J plus 10 equals 2 times B. That's really tempting. And I've seen a lot of folks do J plus 10 equals 2 times B plus 10. And that second one seems to be super popular in this problem. If you take the first equation, J equals B plus 14, which is correct, and then you take J plus 10 equals 2B plus 10, which is not correct, then you'll wind up with 33, which is option E. As in echo, and it looks like about 11% of us are going for that one here. So it's a really popular wrong answer. It has a lot of gravity. It's a subtle but important detail that we need to adjust in that second equation. Because if we do J plus 10 equals 2 times B, and then we just add 10 to the 2B, we're actually doubling Bill's age first, and then we're adding 10 years. But we actually want to go the opposite direction. We want to age him into the future 10 years, and only after that do we want to double it. So to be clear, first he ages 10 years, and then at that point, Jack is twice as old as he is. So we have to get the plus 10 first. We can't do 2 times B plus 10. Otherwise, PEMDAS, order of operations, is going to dictate that we multiply the B by 2 first and then add the 10 later. And that's going to get us the wrong answer. In order to get that relationship right, we'll just use a set of parentheses and we'll write the equation as j plus 10 equals 2 times in parentheses b plus 10. That is the correct way to translate that piece. So that triggers the right order of operations. If you want to refresh on PEMDAS or what I mean by order of operations, we got a Math Basics episode on that linked for you below as well. Okay, so I think the next natural question is how can you make it easier to see and set up the correct relationship? Maybe that's obvious at this point, but I think it's worth discussing. There are a couple options for that, as I mentioned in a recent episode and have mentioned many times in the past. Keeping a list of questions that contain important concepts that you want to master and resolving some of those questions each time you study can really help with the kind of pattern recognition that we're talking about there. So like if you're like, oh man, next time I see an age problem, I really want to remember that parentheses thing, then you could like file this question away in a list and resolve it a few times over the coming weeks or months. That'll definitely help. That's one option. And if that's appealing, then definitely encourage you to use that approach. Another option, which you might suspect, is to use some rows and columns to help you stay organized. Now, this is not a silver bullet, meaning it won't work without some diligence and ingenuity. It's not going to just solve everything by thinking rows and columns and then, the light shines down from the heavens and bestows a great GMAT score on you. But it definitely is really helpful. And hopefully you found it helpful in the previous question and many questions that I've recommended it on in the past. But I wanted to go deep on it here because, yeah, it's clearly an issue. So you can organize these rows and columns however you like. I'm just going to give one potential example to give you an idea. But I'm going to use the time periods in the problem as the column headers. So I might write something like now in the first column, and then I could do 5 years from now, which is what the question's asking, and then 10 years from now, which is what the question's giving me. For me personally, though, I don't find a lot of value in doing it in chronological order. Instead, I just do it in the order that they present it to me in the problem. I find that to be really helpful. So I'll just do now and then 10 years from now for the second column and then 5 years from now for the third column. I can also make some rows. I'll probably make one for Jack and one for Bill. In Jack's row, under the now header, I can just write J for that variable. Or another option there, if you like it, is to just go straight to writing b plus 14. Either one works, and whichever one makes the most sense for you is a good bet. I'm going to just use the J option for now. And then under Bill, now I would probably just write B in both situations. As basic as it might sound, under the in 10 years header, I would write J plus 10 and B plus 10. And then under the in 5 years column, I would just write J plus 5 equals question mark or something like that to remind me, like, what is my objective? What's my North Star? What am I looking to solve for here? From there, a lot of the math is going to be exactly the same as what we just did, but I have found that having that very organized setup really helps cut down on the algebra mistakes, like the missing the parentheses piece or like doing 2B but forgetting to age Bill 10 years in the future at all. That's also really common, like I said. It's quite a similar tip that I gave for word problems a couple months ago, somewhere around episode 26, when I recommended writing some like half math and half English as your notes after you read a word problem, but before you set up an equation. So this rows and columns thing, it's kind of like a version of that, where it's a bridge between the logic of the question and the equations you're going to set up. And just building that bridge in advance in the problem, it really, really helps nail down the right equations because it's really hard to separate the logic that's happening in word problems from the math that's happening in word problems. And I've found if you try to rush into the equation, you often make a mistake in the logic. That's what I was saying on the previous question about like it often feels slower to do a good setup, but it often pays quite a bit in the net gain on time in the question. So because J plus 10 equals 2B plus 10 is super close to being right, and that's just a small difference in logical understanding, having that slightly increased odds that you're going to have the right logical understanding, it could be the difference between getting this question right and wrong. It's like those small little setup differences that compound as you go through the question. You can see from the numbers here, it's super, super easy to mix that up. So while you definitely don't need to use rows and columns here, it does work well, scales really well also, meaning it applies to a wide variety of situations without much modification. So that's why I'm making a push for the rows and columns here. Again, I'd recommend pausing here and asking yourself whether there's something valuable for you to note to yourself based on our discussion. I'll just quickly go through the correct math and the correct solution. So if we set it up properly and we have j equals b plus 14, and then we've got the correct equation of j plus 10 equals 2 times b plus 10 in parentheses, then we can just do some simple order of operations, do some algebra, and solve. So I'd distribute the 2 on the right-hand side of the first equation. So I'd get 2b plus 20 on the right side. I would subtract the 10 from the j plus 10 on the left. Combine some like terms, I would get j equals 2b plus 10. And then I would solve for b in the original equation. J equals b plus 14. I'd subtract 14 from both sides, get b equals j minus 14. And that's because in substitution, I want the b to disappear because I'm solving for j. So we've got a whole math basics episode on that linked below for you called Systems of Equations, how to solve multiple equations at the same time. Might have been a while for you. So I'll substitute in j minus 14 for b. So I'd wind up with j equals 2 times j minus 14 in parentheses, and then plus 10. I'll distribute my 2. So I'll have j equals 2j minus 28 plus 10. So I'll wind up with j equals 2j minus 18. We'll subtract j over from the left side. I'll add 18 over from the right side, and I'll get j equals 18. Now, they were nice to us and they didn't put 18 as one of the answer options. But on a harder version of this question, they might have done that. So that's why you also want to have in your chart j plus 5 equals question mark, and that'll help you get to the right answer, which is 23, which also happens to be option D as in delta. Okay, so again, slight little wrinkle at the end of the problem. They'll often throw that kind of thing in there just to test your organizational skills, test your fortitude, test your mental stamina, test your attention to detail. All the things that most of us would say we admire in great business leaders. Not saying that this test measures your leadership potential perfectly. It definitely doesn't, but they're at least trying to measure those types of skills. And it's a good way to reframe the exam instead of just having it be like this evil thing that's in the way of you and your dreams. Instead, it's a good way to reframe it as like an opportunity to build those skills even before you start business school. I know that might not resonate with a lot of you, but if it's between feeling horrible about it and feeling like it's benefiting you in some way, personally, I would rather look at it the way that makes me feel positive about it, but that might not be your thing. Maybe you thrive on negativity. That's cool. But that's not the majority of people. Okay, so I think that's more than enough on that question. Hopefully you made a good note to self. If you haven't, I'd recommend pausing. Just at least reflect and ask yourself, is there something I want to remember about that from the future that could be helpful? If there isn't, no big deal. And then we'll wrap up with one question that kicks up the difficulty level just a little bit more. Last problem for you. The problem says, a store currently charges the same price for each towel that it sells. If the current price of each towel were to be increased by $1, 10 fewer of the towels could be bought for $120, excluding sales tax. What is the current price of each towel? I'll read that again. A store currently charges the same price for each towel that it sells. If the current price of each towel were to be increased by $1, 10 fewer of the towels could be bought for $120, excluding sales tax. What is the current price of each towel? Option A is $1. Option B is $2. Option C is $3. Option D is $4. And option E is $12. Again, go ahead and pause, see how far you can get on your own. Okay, good follow-up, in my opinion, to our previous problems, and actually a great follow-up to one of the questions we did together in our previous episode about quadratic equations. So hopefully you'll be able to use both of those discussions to your advantage here. First things first, probably comes as no surprise that I recommend writing what's given and asked, and that I recommend noticing we've got a comparison here, an old price, an old quantity, then a new price, and a new quantity. What's tricky for a lot of folks with this question is that the old price and quantity aren't explicitly mentioned in the problem. So you'll need to infer that because there's a new price quantity relationship for $120, then there must be an old price quantity relationship for $120 as well. And that's not necessarily easy for people to do. I've noticed a lot of people get stuck right at the beginning of this problem with that. But what can make that a lot easier is some rows and columns. So just experimenting with hammering a technique here for you. I haven't done this in past episodes, so definitely give us feedback if you like it. If you're like, hey, that's really annoying, please stop. It's not helping me. Then just let us know. We're super open to feedback, and you definitely can't hurt our feelings. Again, we're at the GMAT strategy on current social channels, and you can email us contact at the gmatstrategy.com if you prefer email. Notice that this question asks for the current price of each towel, and that's a hint that there's a current situation as well as the new situation. There's also a hint about that earlier in the problem when we're told if the current price of each towel were to be increased. So that suggests there's a current price and then an increased price of $1 more. So that's your cue that I think some rows and columns would work well, that there's a comparison or like a time change, if that makes sense. So let's set up some column headers. I'd probably say one that says current and then the others it says new or something like that. And then let's set up a row that's labeled price per towel. And from there, we could create a variable for the current price per towel. Why don't we call that P, since that's unknown? And then under the new column, we can write P plus 1. So it says if the current price were increased by $1, it's like, okay, well, I don't know what the current price is. If there's an unknown in the question, that's usually the signal, make a variable that represents that unknown. And then you can operate on that unknown. Once again, using the same technique I used in the first problem, just going back to the given information saying, okay, what have I not used yet? It says 10 fewer towels can be bought for $120. So let's make another row for number of towels. We'll make the current number of towels you can buy for 120 T. Again, that's an unknown. And then under the new column, we can write T minus 10. So again, I think that rows and columns of like current versus new can help you backtrack the inference of like, oh, I need a variable. I need some kind of expression, some kind of relationship for the current situation. And then I can operate and figure out what the new situation is. It's not a silver bullet. It's not going to like fix all your problems or make that easy to do 100% of the time, but it'll definitely help. It'll very highly likely make it easier to spot that, especially if you didn't see that. Okay. If you want, you could make a total row at the bottom and just put 120 at the bottom of each column. So it's $120 originally, and it's $120 in the new situation. Whatever makes most sense to you. I like to do that kind of thing. I just think the more I write down, the better. I already talked about that earlier, but your mileage may vary there. I think this question is like pretty representative of what I'd call like medium difficulty level algebraic translation questions. You'll probably see harder stuff, but you'll definitely see easier stuff as well. And I think a lot of times the bottleneck on that is just getting organized, number one, and number two, having to like backtrack to something that wasn't explicitly mentioned. Again, just a good visual organization system. Hate to sound like a broken record, it usually really helps. So let's say you can get to that place where you got the table filled out. At that point, you can either set up a couple equations or start guessing and testing with the answer choices. Both of those processes work really well. I encourage you to experiment with both. Pick the one that you like best. But just to make sure the algebraic approach is clear and to discuss one of the most common wrong answers, I'm just going to briefly touch on the algebraic solution path. It's a little bit long in terms of steps, so I'm not actually going to go through every single step verbally. But if you want to see it visually, a quick web search will help. And then you obviously can work through the algebra yourself as well. But I am just going to talk about like kind of where you begin and where you get, gloss over that, and then talk about the pitfall here. So What happens if we take that information in the chart and use algebra is we'd get two equations. The first one for the original situation would be P times T equals 120. That's your basic price times quantity equals total cost. So price per towel we set up as P, total towels we set up as T, P times T equals 120. Then the new situation is P minus 1 times T minus 10 equals 120. So that's sorry, not P minus 1, P plus 1. My apologies. Just had a little typo in our notes there. So we're increasing the price per towel by $1. That decreases the quantity of towels I can buy for 120 bucks by 10. That's how we could represent that. Question asks us for P, the current price of each towel. And again, if we use some substitution, we would isolate T in the first equation, substitute in. Again, we got that math basics episode below on substitution if you're a little fuzzy on that. And then you're going to wind up with a quadratic equation. If you do out the math, then you're going to wind up with like a P squared minus blah, 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 blah equals 0. And that's something we were just discussing last week. We've also got a math basics episode linked below for you on quadratic equations if you want or need to upskill on those. Like, what does a quadratic equation mean? How do I solve them? How do I factor them? That kind of stuff. Might have been a while. Might have been a while if you're just starting out. Now, again, the solving piece is a little long. So let's just say that you do all the algebra right and you know how to factor quadratic equations, you would eventually get down to P plus 4 times P minus 3 equals 0. From there, you'd probably figure out that there's two possible solutions that make that equation work, -4 and +3. Now, if you do that properly, you would get +3, which is the right answer to this question. That's option C, as in Charlie. But I'll read the options for you again and just see if you can guess what the most popular wrong answer is. A is 1, B is 2, C is 3, D is 4, E is 12. Remember, the equation we got was P plus 4 times P minus 3 equals 0. If you're thinking the most popular wrong answer is D, $4, then you're right. So about 11% of us are going for that one. And that really hurts. That really, 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 really hurts because at that point, you've done all the math exactly right. And then you're just switching your negative sign in the factored form of P plus 4, P minus 3. So I just wanted to put a little bit of additional attention beyond the rows and columns thing on the, hey, make sure you're solving for the right thing idea, which is just a big, big knife in the side if you're not super careful with that. So if that is happening for you, writing the question at the top of your scratch work really helps with that. Putting a box around the question, circling the question, that can really help with it. And then just double checking each step of your computation. I've talked about that a ton in the past. I know that might sound redundant, but I'm just saying it a lot because for me personally, I generally need to be reminded of things way more than I think I do in order for it to become a habit. Like for me to get to the place where I don't need to put effort into executing on it. So just trying to help that for you and just kind of give what I needed back in the day when I was really struggling with this thing. So if you find yourself making those kinds of mistakes, like choosing D instead of C here because of the negative sign thing, just make that habit, double check every step of your algebra and arithmetic every single time, 100% of the time. And if you struggle to do things 100% of the time, just check out that episode on how to be more consistent. It's called How to Score High Consistently. Okay, so a couple reasons that one might seem a little tougher than the previous two is for sure the math is a bit more intricate. If you actually do the algebra out, there's quite a few more steps than the previous questions. I also think the setup's a little bit less intuitive. I talked about that a good amount. Like you have to infer the original situation, even though it's not explicitly mentioned. So all those things can make that problem a little bit higher on the difficulty scale. About 25% of us missed this one. So 13% of us missed the first one, 20% of us missed the second one, 25% of us missed this one. So just by the numbers, this one's a little bit tougher. I think it makes sense. But hopefully what I talked about there and what we talked about with quadratics in the last episode and some of the math basics that I recommended, I think if you put all that together, you've got really, really good odds of success on this one. So one final time, I recommend you pause here. Just make a note to self if there's anything you want to remember from our discussion about this one. And we'll be back soon with more tips, more strategies, more advice, more walkthroughs, more breakdowns to put you on the fastest possible path to success. That's our objective for you here. As I said, if you have questions or feedback, you can reach us anytime at the GMAT Strategy on current social channels, contact at thegmatstrategy.com for email. We're happy to help. In the meantime, if you want more tips and strategies for optimizing your performance on the exam, just head to our website, thegmatstrategy.com, which is linked below as well. And check out our free video that I mentioned earlier on how you can reach your dream GMAT score in half the normal time. Even just understanding how the algorithm is different from typical exams will help tremendously. In the meantime, this is a regular show, so please subscribe and please stay positive and stay consistent with your studies, everybody. Talk to you all soon.